Hello, everyone, and welcome again to the GNSS Interference Intentional GNSS Jamming and Spoofing webinar. Thank you very much, Shimei, for the introduction, and I will apologize for not having my camera turned on as I ran into some technical difficulties this afternoon. So good morning, good afternoon, and good evening to everyone that is currently joining us. It's a pleasure to join you for this webinar. Again, my name is Nikki Harry-Charon, and I am the Operations Program Manager here at Canzo, and I will be your moderator for the remainder of this 90-minute webinar. Before we dive into today's content, I'd like to highlight that we currently have 555 registered attendees from various regions worldwide, including air navigation service providers and industry professionals. With a broad audience, I realize some of you may not be familiar with Canzo. Therefore, I'd just like to take a few minutes to provide a brief overview of Canzo and its objectives, just recapping the video we just watched. Canzo, or the Civil Air Navigation Services Organization, is the global voice of air traffic management. Canzo's members provide air navigation services to over 90% of the world's air traffic. Our members share information and develop new policies with the goal of improving air navigation services on the ground and in the air. Canzo represents its members' views to a wide range of aviation stakeholders, including the International Civil Aviation Organization, better known as ICAO, where we have official observer status. Canzo also has an extensive network of associate members drawn from across the aviation industry. Canzo focuses on every aspect of aviation where ANSPs play a role. We collaborate with industry associations like ACI, IATA, IFALPA, and IFACA, along with the individual ANSP's industry members and ICAO to enhance the safety and efficiency of the global aviation ecosystem. Our work adheres to best practices and aligns with current ICAO requirements. With that being said, I'm very excited about today's session as it has been such an important topic of conversation. In a few minutes, you will have the opportunity to hear from a few of our experts within our field to discuss GNSS interference, the impacts of aircraft operations and air traffic services resulting from GNSS interference, as well as mitigation strategies for both. Information will also be provided on related conclusions from the 14th ICAO Air Navigation Conference, and Ariane will discuss the use of its global data set and monitoring tools to identify abnormalities in the GNSS signals to an aircraft. As a reminder, the audience will have a chance to ask questions, so please feel free to type your questions into the chat box during the individual presentations, with the understanding that they will be answered at the end of the webinar during our question and answer session. So the presentation will be approximately 60 minutes, and we'll have 30 minutes or so for question and answers. Additionally, an email will be sent to all registered attendees within a few days, so please do not worry about taking notes. Just focus on the content and enjoy the discussion, because you will be able to rewatch the webinar and view the slides whenever it's convenient to you. At this time, I would like to introduce the speakers. Next slide, please. Today, you will hear from Lisa B., Director of Air Traffic Services for Viasat. She's also the co-chair of our Canzo Communication, Navigation, and Surveillance Work Group. You'll also hear from Trubin Nogobi. He is the Senior Systems Engineer, Surveillance and Display Systems for ATNS in South Africa. He also helps Lisa along with the co-chair position in the Canzo CNS Work Group. We'll hear from Ruby Syed, Global Head of Air Traffic Management for IATA. And last but certainly not least, Diego Albert, Director of Sales for Asia for Ariane. I'll hand the floor over to Lisa B. at this time. She will take you through the agenda and start off with the first presentation. Thank you all.
Thank you, Nikki, and welcome everyone to our webinar on GNSS interference with a focus on deliberate interference from jamming and spoofing. Next slide, please. Today, I'll start off by giving you an overview in the context of the issue of deliberate GNSS interference, so that you can understand the urgency with which we're addressing this issue and making sure that everyone in our community is aware of it. And then you'll hear from Ruby Syed and Truman Nobod on the operational impacts and mitigations. Ruby will provide the airline's perspective and Truman will provide the air traffic service provider perspectives in those areas. I'll provide a brief summary of some of the conclusions from ICAO's recent air navigation conference related to GNSS interference. And finally, Diego Albert will provide some very interesting information on GNSS interference monitoring tools that Arion has developed, along with some videos where you can actually visualize some of the issues. And then finally, we'll give a quick summary and then turn it over to Q&A. Next slide, please. So just to provide some context on GNSS vulnerabilities, one of the key issues is that GNSS satellite signals are extremely low power, and so they're particularly vulnerable to interference. Interference can be unintentional and naturally occurring, caused by things such as atmospheric scintillation, solar effects, and also unintentional from things like TV broadcast malfunctions, or interference can be deliberate in the cases of jamming or spoofing in particular. And because GNSS is incorporated into such a large number of aircraft systems, the flight management systems, hybrid IRS, aircraft clocks, ground proximity warning systems, weather radar, controller pilot data link, surveillance technologies like ADS-B and ADS-C, and others, as well as a number of ATM ground systems, the impacts from a spoof GNSS signal are severe and can have cascading results. And so in addition to all of that, the incidence of GNSS interference have been rapidly rising significantly in the last year. And so that's really the driver for the urgency behind the webinar that CANSO asked us to produce. Next slide. So focusing on intentional GNSS interference, spoofing is really a counterfeit satellite signal that's broadcast to deceive GNSS receivers. And the result is incorrect position, navigation, and timing data. This is compounded because spoofing events are not automatically detected, so flight crews don't receive alerts and are usually unaware that their signals have been spoofed. And with few exceptions, GPS and GNSS spoofing is primarily conducted by state actors, and it occurs as a result of regional conflicts. The other type of GNSS interference is from jamming, which is intentional interference with the GNSS signals, and it prevents the receivers from locking onto satellite signals, and it has the main effect of degrading GNSS signals and may render the GNSS system ineffective for users that are operating within the jammed area. Unlike spoofing, jamming effects are generally detected by avionics systems, and operators or flight crews are provided with alerts. And again, the primary jamming sources include military radio frequency interference. It's also being proliferated by the use of personal privacy devices. And while in many, if not most states, deliberately interfering with jamming a GPS signal is not legal, these devices are readily available on the internet. And as I mentioned previously, this can also occur as a result of television broadcast malfunction. Next slide, please. So this is just a depiction to show you that GNSS interference is actually globally occurring. The green areas show low levels of GPS interference, but you can see it's in all regions of the world. And the other colors really focus on areas that are primarily conflict areas. So next slide, please. And in the conflict zone areas, as we zoom in, we can see that the primary areas we're seeing problems are occurring in this southern and eastern Mediterranean area and the Middle East, the Black Sea, Baltic Sea, and Eastern European area, and the Arctic area. And there's another area, Pakistan, India, where we're also seeing effects. Next slide, please. So just to give you an idea of the growth, we began to see a real increase in GNSS spoofing incidents beginning in September 2023. And by January 2024, we were seeing about 300 flights a day impacted. By August this year, we began to see about 1,500 flights per day affected. And between July 15th and August 15th this year, about 41,000 flights were affected by GNSS spoofing. So this, you can see this graphic, which was derived from the Ops Group spoofing report, that shows a severe growth in GNSS spoofing incidents. Next slide, please. So we've already talked about the regional conflict zones, and this is just zeroing in on a specific time frame from July 15th to August 15th. And again, you can see the southern Mediterranean and Middle East areas, India, Pakistan, and the Eastern Europe and Baltic and Black Sea areas are the primary areas for spoofing events. Next slide. In response to this proliferation, there's been a real effort to generate regulatory and industry guidance. And this is just a sampling. This is not all inclusive, so you need to check your own state for information and safety bulletins. But the EU regulation in 2022 addresses the topic. A number of states have published safety and technical information bulletins. EASA, FAA Singapore, and IATA has also published a safety bulletin. A number of papers and reports have been published, two that I'll highlight. IATA, just in this past September, republished their GNSS RFI safety risk assessment. And another good report is the Ops Group GPS spoofing final report of the work group that was published also in September this year. Those are both good resources, and so we've provided a link to them. A number of workshops have been conducted. I showed just one that was held in January, but I know that there have been some additional workshops held just recently. And there are existing ICAO documents that provide some guidance related to the issue. The ICAO Doc 9849, the GNSS Manual, Chapter 5 has some guidance, and Annex 10, Volume 1, Radio Navigation Aids, would provide the SARPs related to GNSS interference. Next slide. So now I'll turn it over to Ruby Syed so she can give you the airline's perspective on operational impacts and mitigations.
Hello, everyone, and thank you, Lisa, for the introduction of the webinar and also the agenda items. So what you shared is actually a very good intro to what I will be presenting today in terms of the operational impacts and mitigations. And if we go to the next slide, please. So complementary to the information and the data that you shared, Lisa, we are, or the airline operators are experiencing an increasing number of GPS loss or loss of GPS signal due to the reasons that you mentioned. Of course, we're seeing the spike in jamming and spoofing events, especially around conflict zones. And while this increasing number of GNSS, let's say, radio interference is prompting everybody to work on mitigations, one of the issues that we need to keep in mind is while we address these issues, we need to make sure that this doesn't become part of the normalized operations, in the sense that we need to keep an eye on it. What we see is that right now there is this expectation that yes, there is a loss of GPS signal in certain areas due to conflict zones, and therefore we sort of expect it. This comes down to international bodies and organizations working to ensure that we address these issues and these root causes, and we'll come back to that in terms of some of the conclusions of the most recent air navigation conference. If we go to the next slide, please. We did a sampling of data with the data that we have from airline operators who are members and even non-members to IATA who contribute with data. The issue that we see is not just the events of the GPS signal loss or the interference with the GNSS receiver. It's about the duration, and the issue is the duration en route or in flight. And as you can see on the chart on the screen, sometimes it's between 60 to over 60 minutes, and in some occasions it was for the duration of the remainder of the flight. And as some of our audience may know, when this happens, then there is a degradation in navigation capabilities. For the pilots or the air crew in the flight deck, there's also loss of some systems, which creates a huge safety impact. So when we talk about the loss of or the interference with GNSS, it's not just about the event itself, it's the impact for the remainder of the flight. And in many cases, it continued until the aircraft landed, and that only then was it possible to do a reset of the receiver while on the ground. So when we talk about how that impacts air navigation, so let's imagine let's consider a situation or a scenario where an aircraft experienced either spoofing or jamming. There was interference with the GNSS receiver, signal was lost, impact on navigation in one location. It continued for the remainder of the flight, which means that impacts the operation of the aircraft in other airspace and the interface with other ANSPs. So in terms of the audience for this webinar, it's very important to keep in mind that although within your airspace, GNSS RFI might not be a high risk, it is becoming an issue when you have aircraft coming into your airspace that have experienced a GPS signal loss somewhere else. And we've seen that in some cases, even in oceanic airspace, where it becomes more of a problem of how we can collectively manage this from an airline perspective and an air navigation service provider perspective. So if we go to the next slide. So Lisa mentioned the risk assessment that is available online for everyone's reference. And you can see there are a lot of best practices. Now, what we are encouraging our member airlines, and we are working with a lot of airlines on, is how you regularly and constantly do the risk assessment. And it was mentioned by Lisa before, and you can see it in other, let's say, presentations. The main issue is around conflict zones. However, we are seeing emerging risks in other areas where it's not related to conflict zone. It is related to a test. It is related to a localized issue within a certain country that affects GPS signal within that country, and by extension within the airspace. So the regular constant risk assessment is needed, especially before flight, and that feeds into the flight planning phase, how the air crew are going to prepare for the flight. There's also the simulator training that a lot of sessions that a lot of airlines are starting to do. They've already done simulator training, but now they're focusing on some of the let's say scenarios of GPS signal loss, and then what are some of the mitigations en route, because when that happens, there are SOPs available for aircrew. There are notifications and briefings, but also it's important to have that training on how you handle these situations en route. And then we have regular engagements with the manufacturers, because at the end of the day, a lot of the mitigation measures or even the recovery for losing a GPS signal en route, it's about technology, and it's about technology on board, and then how you manage those systems and those receivers, and the some of the other, let's say, impacts related to GPS signal loss. So regular engagement with manufacturers is critical and key. We're also working with our counterpart, ICC AIA, on some high-level recommendations. For example, Lisa mentioned workshops and different forums that are addressing this issue. We're working with them on also some education and awareness at a high level, because at the end of the day, the specific recommendations are really tailored per aircraft type. So if we go to the next slide, what I also wanted to highlight here is that the recovery in-flight procedures are the most critical at the moment, and with that, there are conversations between airlines and manufacturers. There are also recommendations from manufacturers per aircraft type on how you manage an in-flight event and what is the recovery. And I'll talk a little bit about how the recovery is going to also impact ANSPs, or navigation service providers. What is critical as well, and what is most important, and we are encouraging member airlines, but also we are encouraging all stakeholders within the system, is to provide the reports, because reporting the event, the impact, the extent, the duration is key in terms of how we're going to work on this, how we're going to address this. And there are short-term, let's say, mitigations that we are working on. You can see some of them in the safety risk assessment available online, or in some of the documents that Lisa mentioned. But we also need to look at this from a holistic perspective, system perspective, and even look at the long-term mitigations. So if we go to the next slide, please. So actions external to airlines, and here because of the audience of the webinar today, I wanted to highlight some of the things that that we are also trying to highlight in terms of what are the controls and the factors external to operators. There's a huge emphasis on the regulatory, let's say, legal aspects. For example, it is considered illegal in most countries, as Lisa mentioned, to own some of these devices that are used for jamming. And although we have an ITU resolution, we still have deliberate jamming and spoofing in certain locations. And this is where the conclusions of the Air Navigation Conference will help us address some of these issues and work with regulators in the different regions to address some of these issues. In some regions, we do have very good civil military, let's say, interface coordination when it comes to GNSS interference and testing. In other regions, we are still not at that level. So we are working with different stakeholders and with our regional offices on how we can increase awareness regarding the impact. Because in a lot of these cases, the interference is not coming from civil aviation, but civil aviation is impacted. So how do we encourage that kind of, let's say, coordination and collaboration, and raise the awareness? there are also some actions in terms of how we work together with the different regions, as I mentioned, for ANSPs to be aware of issues that are not really happening within their airspace, but outside, and yet they impact operation within their airspace. And we're seeing this in different regions. There's an increasing number. So the exchange of best practices has been very helpful so far. Webinars like this hosted by CANSO, we are organizing airline information sessions where airlines are also sharing their issues, sharing best practices amongst ANSPs, and also events where you have experienced aircraft operating with let's say experiencing GPS signal loss in another airspace, but operating within your airspace. How was that managed? What are some of the best practices? This kind of sharing of information is very helpful. The thing that we need to remember is that this issue is not going away anytime soon. So while we keep working on the short-term mitigations, we also need to work on the long-term technological solutions. And this is where working with some stakeholders like the CNS working group of CANSO, the navigation systems panel at ICAO, some of the papers and let's say recommendations that we are working on as IATA with our member airlines. This all feeds into how we can look at resilient systems, and we need to keep that in mind because there are vulnerabilities with onboard equipment. These vulnerabilities are going to exist, and these risks are going to continue to be there. And as an industry, we need to focus on the short term as well as the long term. And this is the approach that we are taking with our stakeholders. And we really appreciate, like I said, this kind of exchange of best practices between different, not just organizations, but also members of the different organizations. And if we go to the last slide, I think in my presentation, I wanted to highlight that a lot of these documents, a lot of these recommendations, even the safety risk assessment, they're all available on our safety issue hub. Everyone has access. You can find this on our website, and you can see here a lot of reference documents from other organizations, also some regulatory documents, manufacturers, and also our safety risk assessment. The key underlining issue or the key underlining recommendation here is continuing working together and sharing best practices, because this topic or this issue impacts everyone. It impacts airline operators, it impacts ANSPs, and also it impacts manufacturers when they look at more resilient systems for the future. And I believe that brings me to the end of my presentation today. So with that, I will hand over to Truman, who will give a different perspective on the issue, the risks, the challenges, and also the mitigations. Thank you, and over to you, Truman.
Thank you very much, Ruby. That was very good, and it allows me to present the next section of the GNSS interference topic. I'll be looking at the impacts, the ATM, from the ATM perspective, and the proposed mitigations. So next slide, please. Thank you. We have established the fact that the GNSS plays a pivotal role when it comes to our technology roadmap as an aviation ecosystem. We are aware that the GNSS plays a critical role in the CNS and ATM operations. What that means is that there's a significance when it comes to enhance navigation precision, because our GNSS technologies, they enable accurate aircraft positioning, reducing navigation errors. This precision allows for more efficient flight paths from an ATM perspective. From a communication point of view, we are aware that GNSS supports communication systems, indirectly supporting CNS operations by providing time synchronization that is required for some data link communication systems. So we are heavily dependent on this system, on this technology for the future, because it also allows increased efficiency. What that means is that GNSS plays a pivotal role when it comes to routing and optimizing of procedures and flight paths, and reducing fuel consumptions for our airlines, as well as emissions, because we are able to then do some RNAVs and RNPs and so forth. Overall, we are aware that GNSS plays a pivotal role in improving air traffic management. What that means is that the GNSS enables more efficient airspace management. It reduces congestion and delays, and it also supports reduced separation standards, which is what we have been geared towards over the past several years as aviation ecosystem. Next slide, please. Thank you. From an avionics perspective, we are also aware that the interference of GNSS has a huge impact, because the avionics systems, they heavily rely on GNSS for navigation, guidance, and surveillance. Some of the potential impacts of GNSS interruptions on avionics include loss of RNAV and RNP, which therefore means that it affects the service provision, leading to fuel emissions and increased congestions in the airspace. It also has an impact on the loss of position information. What it means is that anticipated effects to use conventional navigation aids and ability to auto-tune GNSS outages can also cause aircraft to lose accurate position data. We are all aware of these issues. We are also aware of the fact that inaccurate aircraft position on navigation display systems, electronic flight bags, and moving maps by the airline crew, they get to be affected. From the communication perspective, we've also established the fact that these interferences lead to disrupted data link communication, because the GNSS interruptions can affect our data link communication, such as ADSB. And it also, from a surveillance perspective, we have an impact on the reduced situational awareness. So all these pointers, they indicate to the importance and the critical nature of the GNSS, and the apparent move for our ecosystem to then start to come up with sessions like this and mitigations to look at various ways to handle the situation. So the potential result, obviously, if not monitored, as Rupi had indicated or reported these incidences, or coming up with operational and strategies, we will obviously lead to catastrophic events, increased risk of control flight into terrains, potential for separation errors between aircraft, disrupted performance-based navigations, impact on precision approach and landing systems. The list of issues are endless. So that is why today it is critical for us to look at the mitigations. Next slide, please. Thank you. So from an operational perspective point of view, the impacts from GNSS interferences, they can also be technical in nature. What that means is that failure or degradation of ATM infrastructure and its associated systems that are heavily reliant on GPS and GNSS. So those would be operational impacts experienced by our air traffic controllers, experienced by our engineers and technicians on the ground. Time shifting, we spoke about the time stamping, which is almost all the systems that we are deploying in this day and age depends on the GNSS synchronization and time stamping. So the time shift affecting the ground-based systems using GNSS as a reference for timing. So those are also the issues, abnormal differences between ground speed and true speed on the aircraft, CPDLC and ADSC message corruption errors, at the end of the day, our air traffic controllers may not be even able to detect whether the message is correct or not if these interferences are not monitored accurately. So the potential results, obviously, is the increased risk of control flight into terrain, as I've mentioned earlier, the potential for separation errors between aircraft, and the disruption in our PBN initiatives that we are coming up with. Also, we are looking at new and inventive ways in the UAVs, into UTM operations. All those initiatives that we are coming up with are going to be heavily impacted if these interruptions are not well monitored, reported, and strategies formulated to counter these issues. Next slide, please. Thank you. So the mitigations, obviously, Lisa has indicated various publications that have been crafted and presented to the ecosystem to look at, from a strategic perspective to a tactical perspective to an operational perspective. So from a strategic point of view, Ruby also touched on the fact that we need reporting. So she was touching on the fact that the crew needs to report on these incidences as and when they happen. So from a strategic point of view, obviously our mother body, be it ICAO or be it FAA, we need to start reporting these cases, harmful interferences, to the mother bodies so that we can come up with frameworks and solutions. The most important part about reporting means that we need to work together as an ecosystem. What that means is that we need to establish information sharing groups for aviation sector to manage the risk and for harmonization purposes. There must be more open and cooperative cooperation within the bounds of aviation trust framework. The sharing of intelligence will only happen when there is an established foundation of trust between key aviation stakeholders, because by sharing to the trusted, sharing these incidences to the trusted counterparts and to the ecosystem, we are able to solve the problems of the future, because that becomes a lessons learned for another section to look at. We also need to look at the fact that our states must be able to develop and enforce strong regulatory frameworks governing the use of global navigation satellite system repeaters, pseudolights, spoofers, and jammers, and so forth. So that is very, very critical for us. From ANSP's point of view, we need to ensure that surveillance coverage is resilient to GNSS interferences. What that means is that in the past couple of years, we're moving ahead with GNSS-based systems and deploying critical infrastructure, and then moving away from PSR radars and so forth. But it is apparent that we need to keep these primary radar systems up and running, sweating our assets for an elongated period of time. Especially, we need to consider keeping primary radars for areas where surveillance remains exclusively based on ADS-B. We need to consider appropriate contingency procedures to be available when GNSS jamming and spoofing is detected. So that is from an from an ANSP perspective. Also from ATM or ANSP perspective, we need to ensure that contingency plans include procedures in case of large-scale GNSS jamming and spoofing events. For example, we need to consider keeping ground navigation infrastructure operational, such as our ILSs, our VORs, and our DMEs in support for conventional navigation procedures. For instance, through procedural position reports, we can maintain communication between aircraft and ATC or flight dispatch. That is essential for information to include aircraft position, altitude, and so forth. So it goes to show that we need a balance of both equipage, even on the aircrafts that we are using. So if you're looking at strategic mitigations from both states and ANSPs, we need to provide effective spectrum management and protection of GNSS frequencies. that topic is the core of our future because spectrum is scarce, and it is something that is a dependency to all the systems that we are deploying. So proper management of spectrum by following ICAO document 9718, liaising with our ITU radio regulations and ensuring that our frameworks are intact and regulated and regularly monitored to ensure that our frequencies are not, our frequency spectrum is maintained. So that is very critical. We need to retain specific ground-based navigation aids, as we said, as part of the minimum operational network. That is for both states and ANSPs. Yes, it is a bit of a challenge when it comes to budgeting perspective, but we need to have backup systems because aviation technology is based on contingency initiatives. So where terrestrial navigational aids are needed as part of mitigation strategies, we need to give priority to retention of these DMEs and these ILS systems for future. So it is also significant that we assess the likelihood of the effects of global navigation system vulnerabilities in the airspace and apply as necessary recognized and available mitigation methods. Next slide, please. Thank you. When we're looking at the tactical mitigations, now we're talking to the middle management, and we're also talking to semi-operational management because we've been talking to decision makers and regulatory bodies from a strategic perspective. So from a tactical point of view, we need to provide relevant and timely information to airspace users as appropriate as possible through publication of NOTAMs, AIP supplements, and so forth. So by providing relevant and timely information to airspace users, we are able to establish a process to collect information on GNSS degradation in coordination with relevant and competent authorities. We are able to work together as an ecosystem to share and resolve these issues. In areas affected by GNSS jamming or spoofing, we need to promote the use of conventional navigational aids and procedures as indicated earlier. We need to also be prepared to provide assistance to aircraft using radar vectoring. That talks to training of our ATCs, monitoring closely of our traffic to prevent any deviations from ATC clearances. That is critical for us. So which means our refreshers training must also include these tactical and GNSS interference scenarios for our ATCs to be well equipped. Next slide, please. So I touched on the spectrum. Please go ahead to the next slide. I've touched on the spectrum management because we cannot talk about GNSS solutioning by only by not touching on the spectrum allocation. So this here is a reminder that we have spectrum allocated to the ecosystem. Over the past couple of years, we've seen 4G interferences, we've seen 5G interferences, and so forth. So this talks to monitoring of our spectrum, starting from our lower bands that are used by, I don't know if there are any countries that are still using NDPs, but believe me, I think we need to start from there, looking at interferences from low frequency spectrum to the higher bandwidth. And the tricky part about this, as we move into GNSS, where the allocation is between 1.5 gigahertz and above, interferences begin to play a pivotal role because any interference within the larger and the smaller wavelengths becomes catastrophic. You get to block a lot of technologies that we're using. So you can see the allocation of spectrum starting from 1.5 gigahertz all the way to 30 gigahertz, which is the allocation of our GNSS. So it is therefore critical for us to ensure that we work hand in hand with our communication satellite entities, because the potential impact, as I've mentioned, would be the loss of situational awareness and other things. So the recommendations, they come from all over. We need to come up with MOPs from around the globe. We need to consider exclusion zones, especially there are some satellite applications that would impact, because there is still a deliberate impact to our GNSS. So we need to consider, especially next to TMA and associated operations, all those communication satellites specifically supporting navigation, also supporting communication, but also supporting cell phone networks and so forth must be monitored. And perhaps we need to tilt our antennas next to the airports to ensure that these systems are not interfered with. We need to brief our telecommunication agencies as well on the impact of these, the spectrum interferences, and develop mitigation and technical recommendations going forward. But the predominant mode that we need to find ourselves in is monitoring and reporting. Next slide, please, as we conclude my section. We've touched on the fact that spectrum, obviously, it's scarce. So I've mentioned that if you want to look at more content and the spectrum allocation for our systems, we need to look at ICAO document. I think it's 9874. I did mention, I've mentioned earlier on, to ensure that we still adhere to the frequency allocations allocated to the aviation ecosystem. With that being said, thank you very much for allowing me an opportunity to present. I will hand over to Lisa to take us to carry on the recommendations for ICAO. Thank you.
Thank you, Truman. So I'm going to very quickly go through recommendations from the Air Navigation Conference ICAO recently held. There were 7 working papers and 3 information papers on the subject. It was a big topic of conversation. Next slide, please. So ICAO basically came up with recommendations for states and recommendations for ICAO. And for the states, the recommendations included ensuring that effective mitigation measures are implemented based on measures developed by ICAO and industry. And they included the need to maintain, as Truman mentioned, and Ruby, a sufficient network of conventional nav aids to ensure operational safety and sufficient airspace capacity during times of GNSS interference. They also, those mitigation measures needed to be developed through the planning and implementation regional groups, the PIRGs, and the PIRGs should develop regional or GNSS reporting mechanisms as described in ICAO Doc 9849, which is the GNSS manual. And they're also asking states to work with the industry to provide guidance on detecting GNSS jamming or spoofing and maintaining safe and efficient aircraft operation in case of GNSS anomalies. Next slide. ICAO also provided recommendations for, or the Air Navigation Conference provided recommendations for ICAO actions. First, to develop a standardized implementation package to assist and guide states in implementing effective RFI mitigation measures that should include optimization and rationalization of conventional nav aids commensurate with their local services and to ensure continuity in the provision of air navigation services. They also recommend that ICAO develop guidance on civil-military coordination in relation to harmful interference to GNSS that's originated by or detected by military authorities. And they recommend that ICAO review aircraft minimum equipage lists to ensure compatibility with states' implemented minimum operational networks. So that in a nutshell are the recommendations out of the Air Navigation Conference. And now I will turn it over to Diego Albert, and he's going to provide you a very interesting presentation on GNSS interference monitoring tools.
Thank you very much, Lisa and everybody. Greetings from Singapore. I think you can see me now. So indeed, I think this is a great segue for the next 10 minutes, in which we're going to see a little bit of tangible and operational situations coming from some of the real incidents that we have seen, and also it will help us to give a little bit of insights about what technologies are available out there. Ruby from IATA mentioned about the importance of technology. Truman mentioned about the importance of information sharing, and I believe that this presentation is a good end of those statements. So next slide, please. This was mentioned by Lisa at the very beginning, but I think it's a great refresh. Anomalies can be intentional or unintentional. So when a GPS or a GNSS interference occurs, it could be due to meteorological incidents, terrain, noise, malfunctioning. So nothing particularly intentional. But on the other hand, and probably the one that is actually bringing the attention of most authorities recently is the intentional anomalies. Those are the commonly known, the most famous known as jamming and spoofing. So the idea is to try to provide as much information as possible of what is going on in order to take measures. And I have to reemphasize again the good takes of our colleagues from IATA and Viasat mentioning the importance of cooperation and technology. With no further ado, I want to start introducing some of the ideas that we have already developed. So next slide, please. So before entering into the particularities, we have two questions that we always ask ourselves. The first one is there any way technologically available that we could detect and monitor those GNSS interferences that affect the systems? And the next question, would be, if there is such a compromise, interference, or such an event that is affecting GPS, do we know where is the aircraft? Can we rely on the position provided by the GPS? So those are the two elements that we have put into place in order to develop some of the technologies that we will show next. So yeah, next slide. So what we're going to show and the ways that Ariane is able to monitor GNSS interferences is based on the capabilities that Ariane has to monitor worldwide live ADS-B data. Ariane has 66 payloads over Iridium satellites, which is a constellation that covers worldwide, and we are able to monitor all the fleets worldwide that have an ADS-B transmitter. By looking at the ADS-B, we are able to analyze what is called the peak or the NIC value. Peak stands for position integrity category. That is the value that tells whether we should trust that GPS value or not. In other terms, is the error, is a value from 0 to 14. So when we look at that, we are able to trust the integrity of the GPS. But on the other hand, in some cases, particularly when spoofing occurs, spoofing is information that could look like real, and it doesn't give you a particular information from the peak value that the GPS signal is compromised. In that case, due to the coverage of aerial satellites, we are able to triangulate and provide what we call independent positioning identification. In other words, we don't need the GPS to tell where is the aircraft at that given time. And in fact, we're going to show some videos where we could see the GPS information compared with aerial provided information by our satellites. I think it's going to be a few cases of interest that that the audience might appreciate. So let's go for that. Next one, please. So I think you have to click once more. The most relevant tool for today will be a real-time monitoring tool. In other words, what is going on? Is there any GPS interference happening, GNSS interference happening at any given time in your airspace, and what can we do with that? So we have prepared us a video in which I will try to narrate what is happening, and hopefully will be self-explanatory as well. So next, this is a coverage of the Middle East. We use a software that integrates our ADS-B data. Next, you will see that first of all, the space-based ADS-B data is loaded. So all those dots are real-time traffic. So what we can do is click on each of the aircrafts, and we will be able to see the information of that aircraft, including that peak value that I mentioned. In other words, whether the error of the GPS value is correct or not. But additionally, and very importantly, we are able to recreate the route of any given aircraft and designing what has been the peak value at any given time. And you might see that there are some spaces in the middle. Those are spaces where the GPS signal was lost or compromised. But even most interestingly, because of having stored all the historic information of the region at any given time, we are able to display the underground all the peak values of all the aircraft that has been flying on that region. And you can see those polygons with different colors, where red polygons means that the peak value is very very low. It means that the error is very high. And in other words, there has been significant interference in that region. By clicking at each polygon, you can see the number of aircraft that has been counted and the peak value accumulated. The quantity of the maps that you can see stores information displayed in the last 24 hours or in the last hour. Additionally, the tool also allows to make ad hoc analysis, so you can select one particular area or one particular route. And I have to emphasize, this tool is working real time. This means that you can do that while the traffic is going on. And in one of the use cases that we see very valuable is the fact that air traffic controllers or flight dispatchers are able to assign new routes or give instructions to aircraft to modify the current trajectories in order to avoid areas where you can see that that they shouldn't trust the GPS. So I think it's a very powerful way to look at the GPS monitoring. And I would have to add on that the software that you can see, it's just one tool that can be done. The real, let's say, advantage is to have the real-time global live feed for all the aircraft in the world, and that's particularly the added value of Aerion in this case. I think this is a good example, and particularly in the Middle East, which is a region that it was mentioned quite affected. I would like to go to the next slide, just for the interest of time, because besides having live monitoring feed, we are also able to provide post-event analysis. In other words, having the historical data available, we can recreate areas and analyze what was going on in that particular GPS or GNSS interference. I have a couple of examples of interest. Next, please. This first example happened in Singapore in February of this year. If we do click, you can see it on the left side that there is a real traffic replayed, fast speed, and you will see that there is a small circle of on the shape of a star. We will do a zoom, in which you can see that some transmission from in the middle of the ocean has been happening, and that transmission has been compromising the GPS positioning of the aircraft. When you look at the lines of some of the routes, you see that they have some parallel roads. That means that they've been jumping in and out. So what we can see there is a device in the middle of the ocean compromising the signal of anything that is flying above. We believe it's a ship, a vessel that was transmitting, and maybe unintentionally from the middle of the sea, but certainly that gave a big headache for all the operators flying at that time. This is a case of jamming signal, and quite of a very graphic one. Next one. This one is a little bit more interesting. This happened in Bahrain, and if we do click on the video, on the left hand, you will see that in the recreation of the traffic, there is a very particular circle being designed in the middle. It's almost like a perfect circle, and we have a zoom on the right image. That circle is displaying a very unique shape of what are the aircraft's position, and certainly there were no aircrafts flying in circles there. We believe that this is actually a case of spoofing. So fake information has been provided into the system, into the avionics, whereas the previous one in Singapore was just jamming the signal. In this case in Bahrain, we also got some reports that this spoofing was affecting either other devices, like people running with their watches. The GPS watches also had like very crazy timing running in the Strava, because it was basically reporting that they were running at the speed of a very unusual speed. So interestingly enough, for the sake of another example we'll give later, this circle that we see with a very perfect radius, we have seen it in other places as well, in different parts of the world. I will mention it in a second. Next slide, please. Additionally, we are also able to provide daily maps of the region. This is a very simplistic way of looking at static data. So this map, for example, is from May 2024, so this year, and the map automatically displays the areas where there has been traffic in blue color. Blue color means the peak value is good. You can see that by just positioning the mouse on top of each polygon, it displays the quantity of flights that have been passing by and the average peak value. In other words, how good was the signal, and also displaying what is the significant aircraft and routes that might have been compromised. There is a couple of cases, if I'm not mistaken, it is a Thai Airways flight and a couple of more flying over Yangon. where not only the polygon displayed is red, in which the count is very, very low, but also those particular routes are displaying a peak value below normal, and in some cases is missed and cut completely. So this is not a real-time tool. This is the historic tool for, let's say, daily or weekly analysis of a certain region. So also very interesting as a post-analysis tool. Next slide, please. At the same time, we also are able to identify individual flights. So this is, for instance, a Korean Air flight that we analyzed, and we are able to look at each position available of the ADS-B and understand whether there has been some losses on the peak value from the GPS, and certainly giving information about what is the current status of, well, at the time, the status of the flight. In this particular case, we can see there is an area where there are some jumps, and this is generated automatically by our system, and certainly the peak value was 0. So it might be jamming, it might be spoofing. Next slide, please. Now, probably one of the biggest questions is that, all right, so if we cannot trust the GPS, and assuming that the GPS is providing wrong information, it means that we don't know what is the aircraft, right? So, you know, it's somehow a challenge to understand where is the aircraft if the air traffic controller is not looking at the real position of the aircraft. So for that, we have developed what is our independent position identification and the track. I think it's better if I show you with an example, a real example. Next slide, please. So what we are able to do is we are able to use our own satellite constellation to recreate the real position of the aircraft by using time of difference of arrival. In other words, it's multilateration or triangulation by using our satellites, locating 3 or more satellites to the same point of, in this case, one aircraft. So in other words, we don't need a GPS satellite to tell us where is the aircraft. We are using our own constellation to define that. Next slide will show an example on that. This was, if I'm not wrong, in January this year. I think you can play the video with another click. So the red track is the ADS-B track. In other words, this is what the air traffic controller will see at this moment of time. This was happening over Russian airspace or the neighbors of Russia airspace. Blue is what our independent position is displaying. In other words, blue is our own satellite positioning, displaying what is the aircraft. So as you can see, blue track is giving a very, very, very regular, very straightforward positioning, which is what the aircraft is actually doing, whereas the red track, which is the ADS-B, is certainly being compromised by spoofing or jamming, is providing incredibly irregular jumps in positioning, and certainly should not be trusted as an element for navigation. So this is particularly a unique kind of way to look at ways of locating the aircraft, but certainly due to using our independent satellite constellation. The video goes on and on. This is a real case that we created, but it's particularly visual to see how damaging and how harmful can be a spoofing in a particular plane. And no peak value could tell you whether it's good or bad. In other words, when we look at the peak value, in some cases, peak value can be very solid, and that doesn't mean that it is not spoofing. So that's why having an independent position is one of the best ways to locate the aircraft real time. Next slide, please. I will finish very quickly. A couple of examples. This was another example that happened in December 25th last year, also around Russia. If you can see that in the top image, a small circle is a small dot, a blue dot. That is actually a circle of exactly the same radius as the one that I displayed in Bahrain previous slides. So we believe that there is some kind of like spoofing device in the market that has a presetting value of some radius and has been used in several places, because otherwise it would be such a coincidence. The top image displays what the air traffic controller was able to see. The bottom image is the recreation by using our Ariane reference track by multilateration of our own satellite constellation. Next slide, please. And I will finish with this. This was a particular famous case. I believe that some airlines stopped flying Finnair, if I'm not wrong, into around Russian territory. This was a loss of signal flying from Helsinki to Europe. The signal was lost, and the aircraft had to fly back with no GPS coverage. We were able to recreate on the bottom image the sequence, and indeed it was able to we can see that how the aircraft went back safely. I think that's quite graphic and self-explanatory. Happy to reply to some questions. So please, next slide. Some information is available on our website, and more information can be given you upon your request. And I think this is it from my side. So back to you, Lisa, if I'm not wrong.
Okay, thank you, Diego. And so I really want to get quickly to questions because we're getting a lot of them. And so I won't go through the summary. I'm going to turn it right back to my panelists, Diego, Truman, and Ruby, and ask each of you to give a quick 30-second last words on the subject, and then we'll hand it over to Nikki and to the questions. So we'll start with Ruby.
Thank you, Lisa. From my side, the underlying issue or a conclusion is how we continue working together on the short-term mitigations and on the long term. There's a lot to do. This issue is not going away, and it only takes platforms and collaboration, let's say opportunities like this one to continue the discussion and to continue the work. This is definitely a long haul issue, not a short haul one. Thank you.
Thank you, Ruby. And Truman. You're muted, Truman. We'll send it to Diego, and then never mind.
Okay, sorry about that. Technology. Okay, from my side, I think the take note would be the establishment of information sharing groups because it is a vital point to share these lessons learned, and also to study our frequencies and to monitor them, and also training of our ATCs on various scenarios, and training of our assets, which I forgot to mention. It is critical. From a strategic perspective, the retaining of conventional navigation systems so that we can have backup systems. Thank you.
Thank you, Truman. And finally, hitting cleanup, we'll give it to Diego.
Thank you, Lisa. So technology is available. GPS is here for many years, and probably will be many more years. And satellite systems are certainly the way that aviation is moving towards. We have the tools, we have the knowledge, and together all the stakeholders can set mechanisms in place to detect, analyze all kinds of GPS and satellite interferences through technology tools, working groups. So we believe that these kind of seminars are very helpful to provide awareness, and we hope this is just the beginning of a very fruitful journey.
Thank you, Diego, Ruby, and Truman. And now I'll turn it back over to Nikki, and we can dig into some questions.
Thanks very much, Lisa. So before we move into Q&A session, I'd just like to give my sincere thanks to Lisa, Truman, Ruby, and Diego for your presentations. We received numerous questions throughout the presentations, and while we may not have a lot of time to address them all today, we're thinking of, or we will actually compile them into a document with responses from our panelists, and this document will be available on the Canso website for our members. So let's start by diving into the first question, and I'll direct these two questions to Diego. How do pilots detect spoofing? And when pilots detect or suspect incidents of GNSS spoofing, how do they report to ANSPs?
So, short answer, they cannot. They cannot detect it. They can suspect something is going on. They can feel that something is not quite right. It can be some instabilities, but current avionic systems, and probably this is the challenge, or not all the avionic systems are equipped to provide countermeasures. Reporting to ANSPs, there are some protocols that some regulators are setting, and most likely are voluntarily at this moment of time, and each regulator will have protocols. So in other words, it's still in the very preliminary stage, and for that reason, we believe that technology is probably the only way to make sure that there is an unanimous view of what is going on at any given time to all pilots, aircrafts, and regions. Because again, pilots are extremely busy by flying, and one of the major sources of instruments is certainly GPS. There is no available tools widespread that can tell whether spoofing has been happening. Jamming is a little easier, because jamming can be just detected by losing the signal. But spoofing is certainly one of the biggest challenges in this regard. I hope I replied with your question, sir or madam.
I believe you did. Thanks very much, Diego. Question number 3, how can you differentiate between these accidental interference and these intentional jamming? Ruby, can I direct that one to you?
Yes, absolutely. So the main difference or the main differentiation is whether there's an advanced notification. So in some cases, as an example, there's a military exercise where there is an advanced notification to the aviation stakeholders, including airline operators, so everybody can plan and prepare. It's known. The deliberate, or what sometimes is referred to as the non-NOTAM RFI event, is where there's no notification, there is no information about duration, location, and therefore there is no way to plan. Although right now a lot of these cases or a lot of these geographic locations have become known because they are associated with a conflict zone. It's just that there is no information related to that because of the nature of the military activity or the action. And Lisa mentioned the discussion during the ICAO Air Navigation Conference, and a lot of the discussion was about that. It wasn't about the known, let's say, event of jamming or interference, but it's more about events where there is no information, and airlines, regulators, and ANSPs, and even manufacturers have to work around that and make sure that the right safety measures are in place. And this is the main challenge.
Thank you, Ruby. Does anyone else on the panel want to add to Ruby's answer?
Good. It was a good answer.
Everything was good.
Okay. I will move to to Lisa for this question. Can authentication GNSS services play an important role in the future? What are the plans for more resilience for GNSS services?
So I do know that, that there are plans for dual frequency constellations, which can be somewhat of a mitigator. But from what I'm hearing, this is a long-term technology issue, and there's nothing short-term in play. And I think that's why you're seeing so many recommendations about looking at your minimum operational networks. In other words, how many terrestrial systems do you need to keep in place in order to ensure you have resiliency in the event of loss of GNSS or unreliable GNSS. So ICAO is looking for recommending long-term plans in that arena. I'm going to ask Truman if he has anything else to say about this.
No, I think you've covered everything, Lisa. Thank you very much.
Okay.
Thank you, Lisa. Truman and Ruby, I'm going to direct this next question to the two of you. Can the introduction of new airspace users, such as UAS and higher airspace operations, increase the problems? Truman, I'll go to you first.
Thank you. Certainly not. I think it's the same phenomena like your cell phone. Just because there's a new cell phone user to the network doesn't mean that it will affect the entire, it will affect the frequency, but it will congest a certain bandwidth. So the UAS will have specific frequencies that are allocated to the HAF currently. So it won't be an impact. ATM and UTM operations would not be impacted by that. It would be a congestion. Thank you.
Thank you. Ruby, did you want to add anything to that?
Yeah, so there's the issue of GNSS RFI specifically is not going to be impacted by new entrants to the system. But the introduction of new entrants will affect spectrum as a whole. And as we know, the spectrum issue for aviation is something that we look at in terms of protection, in terms of allocation, in terms of frequency congestion, as Truman mentioned. So yes, it might affect spectrum, and we are in conversations as an aviation industry about, for example, the use of 5G and 6G and the expanded use of 5G and 6G in close proximity to airports. So there is an impact on spectrum in general, and these conversations are separate to the topic that we are discussing today, which is specifically jamming and spoofing of GNSS.
Thank you, Truman and Ruby. Should an airfield have a GNSS monitoring station so they can detect jamming in an early stage? I'll direct that one to Lisa and anyone else on the panel if they'd like to chime in.
And I'm going to do a redirect to Truman.
Okay.
Okay. Thank you for that. I think the research that is currently being done by ACEPT in various spaces, it looks to the models that Diego was talking about earlier on. We need to be monitoring not just interferences within the UTMs and the the airspace, but we need to monitor the entire signal portfolio. So I would say that we definitely need to monitor. There's different models that are being utilized at this very moment. Also, regulatory framework, they propose that we have GNSS monitoring systems prior to deployment of be it G-bus, S-bus, and so forth to confirm that the stability of the signals. So within that forms part of the monitoring of the signals within sorry, this word just flew by. But yeah, within the airspace that we're monitoring traffic on, thanks.
Thank you, Truman. And I'll have you stay on because this question is for both Truman and Ruby. Is there sufficient common understanding between ATC and flight crew on the validity of flight plan indicators such as RNP4, RCP240, etc., when GNSS spoofing is evident?
Maybe Truman, you'd like to go first. I'll comment from the airline perspective, but yeah, go ahead.
Okay. No, that's fine. That's the main reason why we're having these sessions today, because even though the GNSS interference phenomena is, it's not a new concept, but it has been there for a while. But we are encountering new issues within the aviation space. So I wouldn't say that there has been stable and well-established understanding. So that is why there needs to be monitoring, there needs to be training, there needs to be maintaining of a MON within our airspace. Thank you.
Yeah, and if I understand the question correctly, it's more about how these things are seen from the airline perspective and from the ANSP perspective. And the answer is that sometimes we don't look at the data the same way, we don't do the analysis the same way. And that's why having more harmonized way of reporting is really good. And having conversations like this one, these information sharing best practices, it's really critical. In terms of flight planning itself, usually the format is really standardized in terms of also navigation capabilities that need to be included in the flight plan. The issue is not really at the flight planning stage. The more pressing issue is more en route and how you manage that as flight crew and what you see versus what the ANSPs are encountering. And this is where the challenge is. It's more about that part of the operation that we're trying as different stakeholders within the aviation system to make sure that we have the right mitigations and safety measures. And to the question at the beginning to Diego, sometimes it's a wrong indication to the crew. So how do you manage that? And that's part of the issue. How do you manage a faulty indication? And this is where the main risk lies. Thank you.
If you don't mind, I'll add one thing, because one of the impacts that we saw early in the presentation was the refusal of an oceanic clearance. And so if you're trying to fly into oceanic airspace that requires RNP4 and RCP240, the pilot, if you've been spoofed, as we noted, may not be aware that the figure of merit, for example, has been degraded, or and that they're not meeting it. But the air traffic service provider may get an indication that their performance isn't sufficient to be able to use performance-based separation. And so there is a discrepancy between what the pilot understands the capability of the aircraft to be, how it's actually performing because it's been degraded. And so then the pilot doesn't receive that oceanic clearance.
Thank you very much, Lisa, Truman, and Ruby, for that informative answer. Due to time, I'm just going to ask a couple more questions, and like I said, we'll compile these questions into a list and have the panelists answer them, and it will be published on the CANSO website. So there's a question for Diego. Can you explain how position is obtained from Avion's independent positioning system? What airspace is covered by this independent system?
Yeah, so Avion has a worldwide constellation of ADS-B payloads covering the entire surface of the Earth. So that means that we are able to track any aircraft that has ADS-B transmitters at any given time. Oceanic, terrestrial, mountainous areas, deserts, any place. The key component is to look at every ADS-B data that we receive and taking a look at that so-called peak value. Peak is defined by some standards, if I'm not wrong, by RTCA, and is a value from 0 to 14, and tells you the error of your GPS in such a particular moment of time. In other words, we look at the ADS-B data that we receive from our satellites, we look inside that GPS value, peak value, and we are able to track whether the value is correct, good enough, bad, or you shouldn't trust it. That's for jamming. About the spoofing, as mentioned, it's very difficult to detect. What we look is at our own triangulation through the reference track. So through time of difference of arrival, we look at the 3 signals detected, same signal detected by 3 different satellites, and we compare the difference of arrival, and then we are able to track what is the aircraft at that moment. Then we compare it with the GPS given data, and we see the difference. If it's not in the right place, then that means that that signal has been compromised. I think those are the questions. I hope I
Yes.
replied them.
Can you, there's 2 more questions for you, Diego, that came into the chat that I'd like you to answer. So compared to other surveillance sources, how accurate has the Ariane reference track proven to be? And can the aircraft uplink the multilateration track for Iridium constellation?
Sure. So the first question about the quality of the data, it's identical to ground-based ADS-B or multilateration. We are certified by the EASA as an ATS service provider. In other words, our ADS-B data can be used as any other given source of radar, modest radar, ADS-B, multilateration in equal terms. For separation purposes, etc., etc. So there is no any technical difference or any of the other kind from the data you receive through the satellite constellation and other sources. Second question, way more complicated to answer. So at this moment of time, what we have displayed in this presentation is a solution that we have developed. There is no implementation of this solution at this moment. There is an investment to be done by pilots if they want to have that being integrated into the avionics system. In other words, is it technically possible? Yes. Is it currently possible? I don't see any particular let's say momentum at this moment of time where airlines are investing on that. But we believe that this is the way to go. Setting some monitoring tools that are able to give pilot information about what is the real situation. I have to add something else. The regulatory framework for air traffic management, ANSPs and pilots, or what you can do and what you cannot do with technology is very narrow. In other words, our reference track is not a tool that will allow pilots to take unanimous decisions on changing flights. Maybe pilots, they will. ANSPs, no. The ANSPs rely on existing approved technologies. And our technology of reference track is one initiative that we have developed. And in this case, more for situational awareness purposes. We cannot change the GPS for our Ariane satellite value in a flight plan, for instance. But just to summarize, technically, yes, any pilot could receive a reference track. However, this is not something that has been implemented at the moment because airlines are not, at least to my concern, investing on that, and hopefully that will change soon.
Thank you, Diego. I'll end it with this one question directed to Lisa. Technically, what makes the GNSS so vulnerable to jamming in the first place?
So as we noted in the introduction, the GNSS signals are very low power, and that's the primary cause for their vulnerability. I'll hand it over to Truman if you have any other response in addition to the low power.
Yes, it is, Lisa, a low power, and also the fact that the frequencies that are being used in close proximity to one another. That is why there's a lot of interferences, whether intentional or non-intentional. Thank you.
Thank you both. So our time is a little bit over, but thank you all for sticking in there. I just want to keep this brief before we formally close the webinar. I just want to express my gratitude to the Canzo events team for their hard work in making this webinar possible. I would also like to extend my sincere thank you again to the speakers, Lisa, Truman, Ruby, and Diego, for sharing their time and expertise with us. Lastly, but certainly not least, I do want to thank all of our attendees for joining us today. You will receive the presentation slides and a link to the webinar recording, hopefully within the next week or so. And again, we'll compile a list of these questions and have the panelists answer them. If anyone thinks of any additional questions for our speakers, please feel free to email those to me at operations@canzo.org. That is currently up on the screen. I do sincerely hope you enjoyed this event and wish you all the best of luck in your personal and professional lives. Take care and enjoy the rest of your day.